Hey everybody. They put me at a 5 o'clock talk on a Friday, so it's a pretty bigger audience than I expected. Yeah, so when I originally was doing this talk, I expected to have a little bit more allotted time, so it's a little bit of a more nuanced subject, but I think I distilled a little bit of Elastic Subnets down into some basic things that we could talk about. So just to start, Elastic Subnets are technically live right now, but not really live from a practical perspective. You would really need to stake what's called an X-chain token in order to have permissionless subnet. But really in the future, the idea is that you'll have ERC20 tokens, be able to stake those, and that should be coming relatively soon this year. So at a very high level, what is an Elastic Subnet? This is a subnet that has permissionless validation. So if anybody's ever used something like a Cosmos Zone, their own L1, this is kind of what you can do with subnets, which is pretty powerful. So pretty soon, hopefully this summer, you'll be able to create your own subnet, have your own staking token and proof of stake, leverage the Avalanche consensus, which should allow you to build your validator set for as large as it can go, and then be able to do some interesting bootstrapping mechanisms, which I'd like to talk about today. So here are some considerations. I put some Pokemon on here because they're cool. So when you want to think about your own network, there's a lot of considerations in terms of security, incentives, economics, and how those all play together, right? So, a proof of stake network is secured by a token that really, in theory, has only as much value as what's backing it in terms of economic activity. So when you're actually creating this token and this network, if you're not able to attract actual value, if you're not able to accrue fees, you're really not going to be able to secure the network. This is a consideration for anybody building a subnet, and they should be considering it. So practically speaking, what does that mean? If you distill it into simple form, right? If you have a subnet that is generating fees via gas, those fees generally go to validators. If those validators aren't able to earn fees in excess for the ability for the cost to generate to run the hardware, they're not going to run the hardware, right? So they're just going to shut it off. So you need to be thinking about this math when you're bootstrapping this network from day one. All right. So there's a few considerations. What is a staking token? So you're going to create one. It is not possible to create an Elastic Subnet using an existing token as a staking token, meaning something like AVAX or BTC, you can't stake that because those are liquid tokens on other networks, and that's a security concern. Somebody will be able to acquire enough and probably play with your network. So one of the protections of a proof of stake network is it's pretty difficult to be able to acquire enough of that token and circulating supply to be able to pull off some sort of attack from a security perspective. So what is your staking token? What are the amounts that validators need to stake? These are things you need to take into consideration. What is the gas token? They don't need to be the same. I think a lot of people forget about this. So in theory, you could have a network that has USDC as the gas token, USDT, and has a staking token, I don't know, let's call it Pika. So you would buy and burn, let's say if you wanted to create a model where you could have USDC as the gas token, all fees are paid in USDC, and you're able to actually buy and burn the Pika staking token, for example. So from a UX perspective, this is a little bit cleaner, right? Because you have the ability to use something that is more universal than some token that might have a little bit more volatility properties. How do validators generate revenue? This is like getting to the idea of like sort of these economic problems that you'll see. Like you'll see this a lot in Cosmos these days. Networks are generally like spun up. They exist for a certain amount of time, and then they tend to lose validators because the actual activity on the network isn't really generating enough revenue. And if you're not generating enough revenue, once again, the validators aren't going to run the hardware. And you end up in a tough spot. So you want to be thinking about how to make these things sustainable from day one, doing that math from day one. And a lot of this is projection-based, right, just like any startup. How do you get assets to the Elastic Subnet? This is complicated because typically, Elastic Subnets are going to want to be connected to multiple chains. Do you want to be connected to Avalanche C chain, multiple subnets, Ethereum mainnet, L2s, et cetera, right? You want to invite liquidity, depending on what you're doing, or users from everywhere. So if you're doing that, how are you actually making it such that the assets are canonical on your one subnet? Right? Because if you bridge from multiple different places, you could actually be stuck in a situation where you have many USDCs or many Bitcoins in different forms, right? And that's not ideal from a UX perspective. So like these are some of the things that you have to think about. Who's your bridging provider? You know, some of the ones that we've seen so far with subnets are things like Layer 0, XLR. A lot of them will probably use Avalanche warp messaging, which is the native protocol bridging mechanism, similar to like an IBC. And so if they use these types of things, you need to be careful about how you're going from multiple chains into your subnet, and if that's the case, how you're routing it. So one possible solution is you could route everything through the C chain and use Avalanche warp messaging to keep it a little bit more canonical, depending on the use case. So these are some of the things you have to think about. How do you bootstrap validators? Like, how do you find them? You know, where do you get them? There's a lot of people trying to build this. You know, we've talked to many this week, which is very exciting. But really, you know, there's two maybe that I know of so far. There's the Banky Ignite program, which provides a way to have a cheaper cost to running validators. And there's also GoGoPool, right? So these are all providing this service that allows people to spin up validators at a cheaper cost for their subnets. But in reality, what you really want is a robust and diverse validator set for your specific subnet from a geographical perspective, but also from like a, you know, just in terms of different types of institutions running nodes. So those are some early considerations. In terms of bootstrapping, right, node diversity, which we just mentioned, and geographical dispersity are really important. Like we always mention, even if you're doing a permission network, you'd want at least like 7 nodes, just because you want them set up all across the globe, just in case AWS instance is down or something like that. Infrastructure replication, this is really important. Obviously, depending on the user adoption of the subnet and depending on your resources of what you can actually afford, you know, how are you thinking about explorers? It's always ideal to have more than one, right? Because if one's failing or is down, their node fell off, like you want to be able to have the users to be able to look for another explorer. What are the wallet solutions? Once again, you want something that has, you know, the ability to do cross-chain signing like Core. That's great. Or you can use other wallets. RPC nodes are really important. This is like #1 UX that I feel like a lot of chains didn't do a great job on early on, but have since got better. Sufficient and sticky validator stake. We'll talk about this a little bit more, but this is probably one of the more important things as you're thinking about an elastic validator set. And then monitoring systems. One thing I think we found at Ava Labs pretty much is one of the biggest issues is that a lot of people don't run proper monitoring systems for their networks and aren't necessarily aware if their nodes go down or if there's any types of issues or if partner nodes go down. So you want to be able to keep track of that and sort of have good monitoring systems to alert you. Yeah, so some incentivization ideas here. These are just rough ideas that I came up with. This is not at all like, I guess, what you can only do, but here are some interesting ideas, right? You need to think about it for your use case. You're either building an Elastic Subnet for a game, you're building a general purpose chain, like, you know, a different virtual machine, like maybe Move or something like that. Every single use case should approach how they create a token completely differently. But here are some general ideas. Like, I like to use GMX as a model in a lot of ways. I think they've done a good job from a tokenomics perspective. Created some interesting models. But one idea that I think is pretty interesting is this, what I'm calling usage-based escrow, UBE. But basically what you have here is, and if you're not aware, the Avalanche network works as such. In order to validate an Elastic Subnet, you must validate the primary network, right? So basically you're trying to pull validators to your subnet. That's the goal. So right now there's about 1,400 on Avalanche. I think it's like 3,500 on ETH. You're trying to pull all 1,400 ideally. That would be great, right? Most decentralization as possible. So in order to incentivize those 1,400 different validators, what can you do to get them over? And what can you do to get them over in a way that doesn't sacrifice the token in the short term and long term? Well, one model is something like ESGMX. And the way that works is ES stands for escrow. and basically that token unlocks or sort of vests over a certain amount of time based on some preconditions. So, in GMX in particular, in order to vest it, you need to provide liquidity into the protocol, right? So you're actually serving a function for the protocol and vesting the token only if you're doing that. It's not time-based vesting, which is another type of thing, but doesn't really incentivize the participant to participate in the actual protocol. So for a network, what you could do is actually do an ES, whatever the token is, let's call it Pika, ES Pika token, that vests over some amount of time, but only if they're doing something that serves the network. So let's say it's a general purpose subnet, like a different virtual machine. What they could do is you only vest the token if you're staking and you staked for a certain amount of time, or if you provided liquidity into one of the DEXs, and this could be all automated in the smart contracts, right? So, and what you end up with is a scenario whereby they're actually incentivized to care about the token, all right? Because in order to vest it at that later time, they actually would like it to retain its value. And also they're actually providing liquidity and actually providing a service to the network. So that's one model. There's a lot you could play with that. Another one is to use the unvested airdrops to incentivize LPs, right? So this is a little bit of a different model, once again, depending on the subnet's functionality. But effectively here is, if you have to have a DEX on the subnet, you're going to want liquidity providers. If you want liquidity providers, how do you get them to come? You don't want to pay a very high tax. That was sort of the model in 2020 and 2021, where everybody was just paying like 30% of their supply in 6 months just to actually incentivize liquidity that left afterwards. Here you could do different types of airdrops that vested in the ES format over time to actually get that sticky liquidity. I think the Camelot DEX on Arbitrum did a decent job at this, of getting some particular liquidity for a short amount of time. So that's a model to take a look at as well. And then last is this gas-based distribution. This is kind of interesting. I think I sort of took a little bit of the ideas behind Kanto, which was a fun little experiment on Cosmos. And basically here what you do is you would take the UBE model we had up front, right, which is, once again, this usage-based escrow model, right? So you only vest your tokens if you actually do what we want you to optimize for. And in this case, we would choose what that is. Let's say here it's gas-based distribution, meaning like the amount of gas that your address is burning or using per contract would actually define how fast you vest, with some like curve, right? So we have diminishing returns over time. So that's another model that you could do. These are 3 different models. I don't think any of them are great. I don't think any of them are fantastic, but just 3 different ideas to start with. I think one of the coolest things for Avalanche in general is to see how people approach this. Elastic Subnets will unlock, in a lot of ways, what the vision truly was from day one of Avalanche, was to be a network of networks, all talking to each other. And, I wrote this Substack a while ago. I don't think anybody read it, but whatever. Basically, people always ask me, like, oh, like, what's the point of the C chain? Or, like, what do we do with the C chain? There's so many other networks out there, all this stuff. Like, I think our value proposition is unique in a lot of ways from an Avalanche perspective. It's very clear that the Avalanche C chain is the hub from a liquidity perspective, from sort of where everything is bootstrapped, exchange integrations, different integrations with partners. It's a place where everything exists right now. That's not really the case with a lot of network chains out there. They're still trying to figure out who that is. So for us, as Avalanche Warp Messaging, which is, once again, our cross-chain communication protocol, which is still rolling out, as that gets more live, and as we continue to bring up these really cool subnets that we've been announcing, for this talk, I've been using this Pikachu Subnet example, which, if anybody who's played Pokemon, like, super cool game. A lot of people play it, not super complicated, really good for NFTs. Imagine you get a subnet where everybody's just playing with their Pokemon, millions of people on it. They're going to need to access liquidity. They're going to need to access different types of DeFi primitives. They're going to need to access the C chain, right? And so Avalanche Warp Messaging will connect the C chain to those subnets and other subnets And that's a different value proposition if you're a DeFi protocol building anywhere, or if you're a game and you want to attract new users and you want to airdrop your NFTs to them or something like that. So for Avalanche, it's, once again, a little bit different of a value proposition in terms of a network composition than a lot of other networks. We have the C chain that connects everything and the communication protocol that is the bridge between all these different subnets. So the more value that each subnet brings to the network, the more incremental value that accrues to the actual C chain. So we announced the TSM subnet, which I'm really excited about, should be launched sometime this year. That has League of Legends and all those cool games that a lot of people play. The Gunzilla subnet we're really excited about. The guy's been building that game for 3.5 years. That should be launching sometime this summer. The Shrapnel guys, those are all games that have the possibility to have millions of users. If that's the case, how are you going to communicate with them? How are you going to leverage them? And how are you going to do that in a way that is, secure? So that's how we believe sort of the Avalanche vision will play out. And that's why also we think this cross-communication protocol and Elastic Subnets are really important. With Elastic Subnets, the last thing that's really important to understand is that it might not be good for all use cases. Not everything needs a subnet. Some things are fine to be on the seed chain. Some things are fine to be centralized. Some things are fine to use a data availability layer. Really depends on the use case. If you need a chain that, for whatever reason requires permissionless validation, and if it has permissionless validation, can be better served, Elastic Subnet will be a very good solution for you because you can actually build the validator set to be quite large. I would love to see somebody create a subnet that actually made the primary network validators go up because so many people wanted to validate that subnet. And that's where you would see the actual model of Avalanche, bear fruit. So that's all I really got for you guys today. Quick talk on Elastic Subnet, some ideas. I'll probably write a proper blog on some of the tokenomics thoughts and how to bootstrap, and that's it. I hope everybody had a great conference at the Avalanche Summit.